I write a compiler for a small imperative programming language called Elna. The language is Oberon inspired and the compiler is self-hosted and written in itself. So I already used the language itself, but only the features that are already implemented, and not the whole language is implemented yet. And today I start to improve the code generation for global variables. So in the file, after the type definitions, I have a list of global variables, and these global variables can have two types now only. The one type is array, and the another one is the word. Word is actually fine, so it just defines a 4-byte variable, 4-byte because I target RISC-V 32-bit variant, but array is actually not a real type. It just locates a chunk of memory in the file, and the compiler itself has more types now. It has static arrays and records. So this magic array type should be replaced with real type, like for example an array of 20 words or something like this. And here we have LNTIC variable declaration procedure. TIC means that it generates 3 address code from the abstract syntax tree. And actually the first thing that I wanted to do, so here I have an instruction declaration. This declaration is used for all declarations, for procedure declarations and for variable declarations, and actually I think that I should use different types for these things. So an instruction declaration goes actually in this data part. I'm just not sure how I should call this type properly. Let us just call it Elna TAC. I think that I already have some TIC types. No, I do not have any. Oh, Elna TIC operator. So the same way we can define LNTIC static variable, let us say, and it will actually have the same structure. So next, because these declarations are a list of declarations, and therefore each element contains a pointer to the next element or nil. name is the name of the variable, length is the variable is the name length, and body is the variable content itself. So these are probably the fields that we need. I actually would move them to the other TIC types. ELNA TIC instruction. Yeah, I have even a type for TIC instruction, so we put it in here. And actually I think that we can also copy this type. I use this type in two places, in the TIC instructions and then into RTL instructions. RTL being register transfer language, so it is the pass that is done after the 3 address code generation, probably the next pass. And we want to split these types now. I think that the time has come. Exactly, and we insert this thing in here and just will rename it into something like ELNA TIC procedure, probably, or procedure declaration. Static variable. Yeah, let us call just ELNA TIC procedure. And now we can look where they are used. So these variables are allocated here. We say that result has the type ELNA instruction declaration. So what we allocate here, we allocate here variables, so we can use the concrete type, but the result is probably a bit different because it is a list of all declarations, so the result is probably a more generic type. I should probably split this ELNA instruction declaration also in ELNA RTL declaration yeah. So we allocate here ELNA TIC static variable, but it will what contain all the fields, so we need first fix with this instruction declaration type so that it is a bit smaller. For that we want to copy this type once again, because it is also used for the RTL declaration, and here we have the RTL types, and I think that we also have an RTL instruction, and here the register definitions, RTL info. Let us put here this type and call it basically RTL declaration, and before we continue we'll just look where this type is used and just fix the places and use the proper type. So I go to the beginning of the file and then look for the usages of ELNA declaration. And the first usage is ELNA allocate procedure. Let me see how it is called. So it is called with the code part. I actually save the procedures and variables separately, so I do not need the common type for them actually. Yeah, this also could be separate lists. Okay, we do not need this RTL type for now, or we will need this type, but not now. Now we only have this LNTC procedure and static variable types, and this actually should be enough, I hope. And I was here, I think, and we can really say that our result is a list of these LNTC static variables. So we say that LNTC static variable pointer, and here we say that we allocate LNTC static variable. We say that the next element is nil. We set the body to the size, so this is actually type size. We leave it as is for now, but we'll come back here. In the first step, I want just to split this procedure and static variable types, and then we fix the field names in the static variable type. So this should be fine. Let us see where this procedure is called. TSC variable declaration. So it assigns this value to the node, and this node is instruction declaration, and we use it probably for procedures and for the variables. So I was in the variable declaration, we use it for procedures and variables. And here I iterate for the variables and call LNTC variable declaration for each variable and return. This procedure actually passes only the variable declarations. So this thing is actually also a static variable, and this is probably enough. So we can try to compile this thing once again, and it crashes, of course. ELNA TAC static variable. Okay, current variable and first variable actually have the same type, because it is just the first element of the list and the current list element. List handling should be definitely improved. So let us now look where this thing is called, but I suppose so. This is the call, and we generate data part, and then we generate this ELNA instruction module. And data part is actually not a word, but it is the type returned by the ELNA-TSC word part procedure, so it will be ELNA-TSC static variable. This should be actually enough. So we allocate now less memory because we do not allocate the memory for the fields that are required only for the procedures. But the next step would be, so after the 3 address code generated, the RTL pass is the next pass, and it will accept this data part as argument, and this is the next place that we have to fix. So it gets this an instruction module, and then it gets the data type from the TIC module and passes it to the ELNA RTL globals. And this is basically the same, the next function we are interested in, because we need to fix here the type. The type here will be TIC static variable and TIC procedure, and it is then passed. This should be actually nil, and this thing is then passed to this ELNA RTL global declaration that will have the same type here. So it will be TIC static variable, and result. Okay, this function then allocates instruction declaration for the RTL pass. This is fine because RTL still handles with this old type, and it returns it to the first type, and TC procedure is reassigned here, next copy and first copy. So current copy is the same as the first copy, and the first copy is this RTL declaration. And next copy will be the same. Okay, this is fine. This should be nil as well. And I think that this thing is also done. So here we become TIC declaration, and we read only name, length and body from it, and we assign next to nil. So then we can go back to the TIC pass. What was it? Global variable? No. Just variable? Yes. So what here actually happens is that we allocate the memory for this variable. We get a variable type from the parser tree, and I think that it is the real type. So I have two type representations. The one type representation is the parse type, so the type from the abstract syntax tree, and the other one is kind of type representation that is used in other parsers and that contains additional information like the type size and stuff like this, that is used in the symbol table. And if we look there, this type is assigned. So for example, this one is the parser type declaration, and here we parse a type expression, variable type 1. Should be just variable type. Let us rename it. Okay. Why we have this name and name length variables? Okay, they are just saved. I have a few functions in the type analysis parse, and the one that we are interested in is this variable type, and we actually do a lookup. No, the real type would be in the type declaration and not in the type variable. So this is probably the parse type and not the type info we actually need. Let us check whether we visit this nodes at all and set the type info. It will be what do I want? Actually, new line. So the compiler outputs assembly, and we just put a comment into the assembly file with the data we need. And what is variable type? ELNA3 named type expression. No, variable type is not interesting. What is interesting is actually parser tree, and we want just we do not need a string. We want just to display a pointer whether it is null or not. Type declaration, and we can compile it now. So what is parser tree? Parser tree is ELNA3 variable declaration. ELNA3 variable declaration, and it actually does not have a type expression at all. Type expression, type declaration at all. Now I think that I only saved the type declaration in the expressions and not in the declarations, and we actually do not need them really for the declaration. We have a type name, so let us try a different thing. We will just look into the symbol table, and I think that I have global symbol table variable or something like this. Symbol table global. Oops. Exactly, this variable, and I have or let us write at least the variable name so I do not forget global name. And now we need a function that does a lookup. I think this is this symbol table lookup function. We pass this symbol table global to it, and then the name that we need, and the name would be the parser tree name with its length. So it will return something like, let us do it, we need a temporary variable. The type doesn't matter currently, and I just assign the result to this variable, and then we want to treat this variable as pointer and see whether it is nil or not. So now let us open the assembly of the generated the assembly of the 19th stage. Yes, the type is there in the symbol table. I actually think that the thing that we have in the symbol table is not the type itself, but type info. The output, this is this comment, this is the output from the function, so it is comment with an address. Let us look for the type info, and type info has only the symbol info kind and the type itself. So we can assign the proper type to this thing. It will be a symbol info. Let us call also just type info instead of t. Type info, and here we print type info, and then we get the type that is inside this type info object. Let us print the kind of this symbol, because at least any symbol, I'm a bit stupid. Now it should work. Okay, and the type inside is always nil, and this is not a good thing. It means that we need to provide the proper type for this symbol. I wonder where the type is inserted. So we look for the table inter function into the global symbol table, and this is the place where I insert procedures. So it is during the name analysis pass. The functions from the from this pass begin with the name prefix, so a name procedure declaration, and this is probably built-in types. They are not interesting at all. Type declaration. I actually cannot just look up the type. This is nonsense. it isn't always a named type that I can look up. It can be as well a more complex type that doesn't have a name, like a static array or a pointer type. Do I have something like LNTC type expression? Probably not. So here I have a procedure that sets that inserts a local variable into the symbol table, into the local symbol table of the procedure, and this is actually the function that gets the type and converts abstract syntax to read type into type info object, and then or into a type object, and then it creates this temporary info variable and saves the variable and variable type into a symbol table info object. And I suppose that this is also the way how it should be handled for the global variables. So I find this function once again in the bottom half of the screen. This is this temporary function, and then here I look for the name pass for the procedure temporaries. This should they should be called somewhere from the procedure declaration. Exactly, name procedure declaration, name procedure declaration, and this one is called from name module declaration, and here we call these functions for the procedures, for the for the procedure variables, for local variables, but it is probably for the globals. For the globals we actually call the same function as I see. So I get globals, I check whether they are nil, and I call this name procedure temporary variable. Then I get the next symbol and do a loop. So actually they should be already set. And here I take the variable name, I check the type, I see. So my error seems to be it was here. So I have here parser tree name and length, but name and length is of course not the name and length for the type, but of the variable. The type is variable type. Yes, that makes sense. So this type info is not a type info, it will be a variable info, or I call it temporary info. It should probably be renamed, and this temporary info, I think, should it be. So we change the type of this info object, and it would mean that we can access offset and variable type, and variable type should be actually the type object we are looking for. I will try to compile this thing. It will probably crash. The offset is 0, therefore we got probably nil as the type, yes. In the output, because he is offset the second field, and when we called this type on the type info object, but the real object was temporary info, it also returned the value from this offset field, and it is probably 0. So type won't be available because it is called variable type. And we also renamed this info object into variable info. And now let us try again. Rake just does some additional tests that the compiler works, but it takes some time. So I execute it from time to time just to be sure that nothing is completely broken. So we go back into the assembly file, and it is at least set to some address, and actually to two addresses. That looks actually fine because we have some word variables and we have some array variables. So we have 4 array variables. This is this address 4 times, and 2, 3, 4, 5, 6, 7, and probably 7 word variables. Yes, that looks much better. So now we have the Elna type thing, and I think that Elna type will also have the size as one of its fields. Elna type, exactly, it has size, and the size is actually everything we need, so we can just print size in here. It will compile. The assembly will contain 4 bytes, and then what is it for 4 kilobytes for this array type. Okay, and actually everything that we want to replace this with procedure. Result body, we want set it to the type size, so we can just assign the real size here, and then this thing can be probably removed. The compiler still seems to be okay. So we can remove this output. We do not need the variable type anymore, probably, because it is parsed during the name resolution pass. So this can be removed, and result and variable info is actually needed, and we can just put all this stuff together, but now we should be fine, I think. And here we just insert it into the global symbol table. With the size. So I actually defined this array type as a real type with the static size, with the compiler defined size. But now we can remove this type. But I think we can actually remove it from this stage. No. The problem that we have is that these array variables, we can replace them with arrays in this stage because the previous stage of the compiler won't be able to compile them. So we need to backport our changes or define a new stage. And I think that we actually haven't changed that much, so we can probably just backport them. We do not really need to backport everything. Really only the changes to this function that I do not see. Yes, to this LNTC variable declaration function. Only these changes are actually meaningful. So let us just go to the stage 18 and we will try to backport this stuff. We will have here the same array code, and in the bottom half we open the current 19th stage, and we will find the same procedure declaration. It is LNTC variable declaration, and so we allocate memory, and we have here an additional type being variable info. It is temporary info type. Then we assign it with a lookup. Actually, I do not know if I already have here this expression support. So instead of accessing the fields, yeah, this actually should be fine, but okay, doesn't matter. We just replace them with name and length. I do not know if I can pass field access to functions in this stage already. Name length. This is variable type, and I just need to assign to the result body the size of variable info type. Body, exactly, variable info, variable type, and size. Yeah, well, let us just try it. If it doesn't work, we can revert the changes. So actually I want that variable type is ELNA type. Variable type should be ELNA type. And variable type is not the parser type, but it is the type from the variable info, variable type, variable info, variable type, and then we can access the size from this type. So variable info type, lookup, assignment. Then we have next, name, length, and body, and this stuff isn't needed anymore. Name, length. Okay, it compiles at least as it seems, and then we execute rec and it doesn't print anything. That means that we are fine. And now we can change the actual type of this stuff. So we want to replace these array types with arrays of the same size, just for the compatibility, and it was this size, and if we define it using the word size, then we would have 1024 words. And if we try to compile this, it's still the wrong type for the symbol table, of course. I should implement a hash table for the symbols a bit later, but we still need to implement a few more features. At least we do not have so just it's still just a chunk of memory, but at least we do not need this spatial array type anymore, but we can use the types that we already have. And word is a machine word, so it is for byte for RISC-V 32 bits. So this is fine. I think that we can also remove the code that adds this build type to the symbol table, so it can go as well. Rake doesn't say anything. This is fine, and this is the actual problem that is I have this assign add functions that I used before I had arrays, but since we do have arrays now, probably we can handle it better. So we do not need the 18th stage anymore, By the way, we can just write here, so record fields can be aggregates themselves, static arrays. Yeah, this is actually part of static arrays, I just haven't implemented it. No, these are not only static arrays. This is a general change that global variables can have any valid type. Okay, then we can leave the 18th state and go back to the 19th. This will take a few seconds more because we also compile the 18th stage. I'm going to leave it here today.